So let's see how to use the contents of Boolean variables. For example, here we have the basic Boolean operators, which are the same as the basic logical operators, not, and or. And remember, this is here as a pro tip, if you have other Boolean operators like the implication or, I don't know, NAND, NOR, whatever, you can make them all actually with only two of these. Okay, but we have three. We have not, and or. You can even import the NAND or the implication or whatever you want, the logical gates from some Python libraries, but we will not be needing them. If you ever need them, you can have them. But for now, let's say that basically Python has these three logical operators, these three ways to combine Boolean values. Okay? And how do they work? Well, exactly as you would expect. And you can make truth tables for each of them. For example, the truth table for not is very, very simple. Not only is a unary operator, so only receives one value. And this value can either be true or false. And here we have the whole truth table. The truth value of not true is false, and the truth value of not false is true. And this defines absolutely how the not operator works. And we can do the same for and for or, and we could create the other logical operators and do their truth tables here. And here, for example, you have the truth table of the AND operator. True and true is true, and basically that's it. True and anything else is false, and false and true is also false, and false is also false, of course. Okay, here you have a small exercise to make the truth table of OR, and it will help you work a little bit with operators, and also you can copy this code and repurpose it for solving this example. Okay, and here you have also another small problem with Boolean variables, and take your time to do them, because the only way of learning how to program is actually sitting down and programming yourself. Okay, Python has many built-in functions that return Boolean values. So, for example, in is one of those, but there are many. The in function basically takes some container. In this case, for example, let's consider a string to be a container of characters, and the in tells us if one element is inside of the container or not. So, for example, let's copy this to our other notebook and just run it. Okay, so we have a string here and the character that we want to search, A, and because A is in here, when we print does the character appear in the string and we put it in this belong Boolean variable, we get that yes, it's true. This Boolean variable is evaluated to true because A appears here. If we change this for, I don't know, Z, then this will be evaluated to false. Okay, this is what the in Python built-in function does, and there are many of them. For example, here we have an example with is, which is a similar type of function that you can read all about here and in the linked course. This is just to show that these contents are very basic, but they are used all over the courses that start with basic Python programming and end with deep learning for drone image processing. So, and for processing other things. So in programming, you learn the concepts one at a time, but the point is to be able to use them all together. None of the concepts are anything too completely difficult, but we built a building using them as building blocks, and being able to use them, to juggle them all together at the same time is what makes a good programmer. So programming is not about being able to dig very deep and really master concepts that are very difficult, but to go wide and use many rather simple concepts at the same time. Of course, The most frequent functions, or in this case operators, that return Boolean values are the comparison, and we saw one before, but here we have more. Smaller than, smaller or equal, bigger or equal, etc. Okay, these operators can, of course, the result of these operators can, of course, be combined with the logical operators that we saw before, and or not. For example, print A is smaller than B and B is smaller than A, that's always going to be false. Or A is smaller or equal than B, or B is smaller than A is always going to be true, regardless of what values I choose here. These values can be used linked, as we are seeing here, and here we have others, and I can chain them. I can make changes with them. So I can use more than one in the same operation, and I can do that using and or I can do that also as mathematical expressions, just using the comparison operators. For example, this means 2 is smaller than A and A is smaller than 10. These two are equivalent. In one I have used and in the other I have used a chain of operators. Basically what you would expect from how to use operators from the intuition that we have from math. Python links to that and works exactly as that, as you would expect it to work. One important property is this short circuit evaluation. Basically, the point here is that when we have composite conditions, if one of them becomes in such a way that it determines the result of the whole expression, then we stop evaluating. For example, in this case, we have an OR chain. In an OR chain, if one of them becomes true, then the whole thing is going to be true. It doesn't matter what the other values are. If this one is true, it's always going to be true. So for example, here, if I change A to 50, this will become true, and then the whole expression will become true. And very importantly, the rest of expressions will not even be evaluated. This is used sometimes when the result of this might affect, because of some previous code, whether or not this has been defined. So I can do it in such a way that I don't need to evaluate variables that might not have been defined if I set up things in the proper order.